invisible, explosive, flammable, deadly. These words all describe hydrogen sulfide, or H2S, a leading cause of death in the workplace. Hydrogen sulfide is a byproduct formed by decaying organic matter. Hydrogen sulfide can be found in oil or gas operations, mining facilities, sewage, wastewater treatment plants, landfills, public utilities, and other places. Because hydrogen sulfide is so dangerous, your employer is required to follow certain safety standards, such as monitoring the air in your workspace and providing engineering controls. But most importantly, you must know how to protect yourself. If you are aware of the hazards and follow your company's established procedures, you can work around H2S safely. What exactly is hydrogen sulfide? It's a highly toxic, colorless gas whose molecules consist of two hydrogen atoms bonded to a single atom of sulfur. This molecule poses a direct threat to your life and health if not treated with the proper respect and personal protective equipment. H2S has an offensive odor similar to that of rotten eggs at low concentrations. That's why it's often referred to as sour gas, stink gas, or sour damp. Hydrogen sulfide rapidly deadens your sense of smell, so your nose is a poor first line of defense. Don't rely on your nose to alert you to the presence of H2S. Because of its rapid action, hydrogen sulfide is considered one of the most dangerous industrial gases. H2S is also highly flammable. It has a flash point of 500 degrees Fahrenheit, meaning it will catch fire and burn at any temperature at or above 500 degrees if conditions are right. 500 degrees is lower than you might think when you consider that the end of a cigarette burns at approximately 1400 degrees. That's why smoking is prohibited in or near any area where there's a possibility of H2S. An oxygen acetylene torch burns at approximately 1200 degrees Fahrenheit. Therefore, if any welding or cutting operation must be done, a hot work permit must be obtained before work begins. H2S is water-soluble. The gas may be present in water and will stay mixed with the water until the water is agitated, then it's released into the air. H2S is also highly corrosive to certain metals and can cause a buildup of iron sulfide scale inside the pipe. When the moisture is removed from this compound, it can spontaneously combust and burn on its own. Prolonged contact with H2S may corrode and weaken metal pipes, resulting in a major H2S leak and/or exposure incidents. H2S is recoverable from natural gas and petroleum refining operations and is converted into sulfuric acid or high-quality sulfur. It is also disposed of by burning in flares. When burned, it produces another poisonous gas, sulfur dioxide, or SO2. SO2 is toxic, irritating to the eyes, and can also cause serious injury or death. There are many different hazards associated with this poisonous gas. The main hazard is inhalation. Absorption of the material through the skin is not considered a significant hazard. Low levels of exposure may cause the following symptoms individually or in combinations, increasing with longer exposure: fatigue, eye irritation, headache, dizziness, excitement, coughing, drowsiness, nausea, pain in the nose, throat, and chest. Higher levels of exposure can intensify symptoms, and if the concentration is high enough, death can result. When a person breathes in H2S, it goes directly through the lungs and into the bloodstream. To protect itself, the body oxidizes or breaks down the H2S as rapidly as possible into a harmless compound. If the individual breathes in so much H2S that the body can't oxidize it all, the H2S builds up in the blood and the individual is poisoned. The nerve centers in the brain that control breathing are paralyzed. The lungs stop working and the person is asphyxiated. The way H2S affects you depends on the following factors: duration, or the length of time the individual is exposed; frequency, how often the person is exposed; intensity, how high a concentration the individual was exposed to; and individual susceptibility, or the person's physiological makeup. Studies have shown that symptoms of H2S exposure vary considerably because of individual physiological makeup. You cannot develop a tolerance for H2S. In fact, people who have been exposed to H2S in the past may be more susceptible than those with no history of exposure. Another factor to consider is alcohol. Of course, alcohol use is prohibited at your workplace, but individuals who have consumed alcohol within 24 hours of an H2S exposure have been overcome by unusually low concentrations. Alcohol and H2S do not mix. At 0.13 parts per million, there is a minimal perceptible odor. At 4.60 parts per million, there is an easily detectable moderate odor. At 10 parts per million, eye irritation begins. 10 parts per million is the permissible exposure limit established by OSHA. At 27 parts per million, there is a strong, unpleasant odor. At 100 parts per million, there is coughing, eye irritation, and a loss of smell after 2 to 15 minutes. At 200 to 300 parts per million, there is marked eye inflammation and respiratory tract irritation after 1 hour of exposure. At 500 to 700 parts per million, there will be rapid unconsciousness, cessation of breathing, and death. At 1,000 parts per million and above, the victim falls unconscious immediately and dies within a few minutes. The threshold limit value, or TLV, of H2S is 10 parts per million. The short-term exposure limit, or STEL, is 15 parts per million. The IDLH, or immediate danger to life and health of H2S, is 100 parts per million. The PEL, or permissible exposure limit, is 10 parts per million as established by OSHA. Anyone assigned to a work area that has a concentration of more than 10 parts per million of H2S must wear protective breathing equipment. The most common of these is self-contained breathing apparatus, or SCBA. If worn properly, this SCBA will protect the wearer from the potential dangers of H2S. If not worn properly, it does nothing at all. That is why you must be trained in proper respiratory protection procedures and know how to fit test your equipment properly. Sideburns below the ear, beards and mustaches extending below the lower lip will prevent the wearer from achieving a proper seal. Eyeglasses also prevent a good seal. And of course, contact lenses should never be worn in any industrial environment. Air supply apparatus connect the worker by way of a hose to a fresh air supply. Regardless of what type of protection you use, you can't afford not to know how to use it properly. If you have questions about your equipment or your ability to wear it safely, please ask your supervisor. There are different types of devices used to monitor a work site for H2S gas. Mechanical detectors incorporate a pump, detector tube, and a scale to give readings of H2S. The pump draws air to be tested through the detector tube to react with acetate silicate gel granules. Presence of H2S is shown by the development of a dark brown stain in the granules. Anytime a situation requires you to use a handheld detector, you are required to wear the proper respiratory protective equipment. On most permanent installations, or where there is a continuous possibility of encountering H2S, electronic monitors are installed to give an additional measure of protection to personnel. These electronic units continuously monitor the area for H2S. When the level of H2S reaches an established point, an alarm is triggered. There are usually 2 alarm points. The first is at 10 parts per million, and the second is at 20 parts per million. The first alarm is usually a visual alarm, and the second alarm is usually audible. It's important to know what the alarms and settings are for your particular location. Occasionally, there are malfunctions and false alarms. These can be attributed to wetting or drenching a sensor with water or other fluid, cutting the power cord to the sensor, turning off the monitor's power supply, hitting or banging on the sensor or monitor, and some radio transmissions which may jam the monitor. However, every alarm should be treated as the real thing until proven otherwise by qualified personnel. On all H2S locations, windsocks and wind direction indicators that are easily seen must be installed. It's important that you remain wind conscious at all times. If the H2S alarm sounds, you should move upwind quickly and, if possible, uphill. The reason for this is simple. H2S is heavier than air. This means that the gas will collect in low-lying areas. Unless the H2S is dispersed, it will remain concentrated. So move away from any low-lying area and upwind in the event of an alarm. As well as having an entrance to the location, there must also be a secondary escape route. These should be set up with the wind in mind as well. There should also be at least 2 briefing areas. These briefing areas must be at least 250 feet away from H2S areas and upwind. Personnel should be able to evacuate the location from either of the briefing areas. These briefing areas should have a sign prominently displayed so they can be seen from anywhere on the location. These briefing areas are also used as refill stations for SCBA. In the event of an alarm, all personnel must report to this designated briefing area. All non-essential personnel will be evacuated